Light travels incredibly fast. In fact, it's so fast that it can circle the Earth more than 7 times in just 1 second. It's the fastest thing we know of in the entire universe. Nothing else even comes close to matching its speed. But what exactly is the speed of light? How do we measure something that moves so quickly? Imagine a beam of light racing through space. It's moving at an astonishing speed of approximately 299,792 kilometers per second, or about 186,282 miles per second. That beam has a speed, a specific rate at which it covers distance. This speed is constant and doesn't change no matter what. This speed is what we call the speed of light. It's a universal constant, meaning it's the same everywhere in the universe. The speed of light is a fundamental concept in physics and astronomy. It forms the basis for many theories and equations, including Einstein's theory of relativity. It helps us understand how light travels from distant stars and galaxies to our eyes here on Earth. Without this knowledge, we wouldn't be able to study the universe in the way we do. It also plays a crucial role in technologies like GPS, and even in our understanding of time itself. GPS satellites rely on the speed of light to provide accurate location data, and our perception of time is influenced by how light travels. So, the next time you see sunlight or use a GPS device, remember the incredible journey light takes and the speed at which it travels. It's a reminder of the fascinating and complex nature of our universe. Scientists have meticulously measured the speed of light, a fundamental constant in the universe. In the vast emptiness of space, light zips along at a staggering 299,792,458 meters per second. That's incredibly fast. Imagine traveling at such a speed, it's almost beyond human comprehension. To put it into perspective, light could circle the Earth over 7 times in just 1 second. This means that in the blink of an eye, light has already traveled around our planet multiple times. This speed is so significant that it's denoted by its own symbol, the letter C. The symbol C is universally recognized in the scientific community. Whenever you see C in a physics equation, it represents the speed of light. This symbol is not just a letter, it's a representation of one of the most important constants in physics. This constant is a cornerstone of many scientific theories and calculations. From Einstein's theory of relativity to modern quantum mechanics, the speed of light plays a crucial role. It helps scientists understand the fabric of space and time, and it's essential in the study of the universe. The speed of light is not just a measurement, it's a fundamental constant in the universe. This means that the speed of light is always the same, no matter where you are or how fast you are moving. It's a universal speed limit, and nothing in the cosmos can travel faster. This concept has profound implications for our understanding of the universe. It led Albert Einstein to develop his theory of special relativity, which revolutionized our understanding of space, time, and gravity. Light speed in our world. Even though the speed of light is mind-bogglingly fast, we experience its effects in our everyday lives. Light travels at an astonishing speed of approximately 299,792 kilometers per second, or about 186,282 miles per second. This incredible speed is fundamental to many aspects of our daily experiences. When you flip a light switch, the room seems to illuminate instantly. This is because light travels so quickly that the delay is imperceptible to the human eye. The photons emitted by the light bulb reach every corner of the room almost immediately. That's because light travels so quickly that the time it takes to reach your eyes is practically instantaneous. This rapid travel time is what allows us to see the world around us in real time without any noticeable delay. However, the finite speed of light becomes more noticeable over vast distances. In the vast expanse of space, light's speed, though incredibly fast, is not instantaneous. This is why we see stars as they were years or even centuries ago. For example, it takes about 1.3 seconds for light to travel from the moon to Earth. This means that the light we see from the moon is slightly delayed, giving us a glimpse into the past. So, when we look at the moon, we're actually seeing it as it was 1.3 seconds ago. This phenomenon is even more pronounced with objects farther away, such as the sun, which we see as it was about 8 minutes ago. The farther we look into space, the further back in time we see. Gazing into the past. This concept of seeing objects as they were in the past becomes even more pronounced when we look at distant stars and galaxies. Light from these celestial objects takes years, centuries, or even billions of years to reach us. When astronomers observe a galaxy billions of light years away, they're not seeing it as it is now, but as it was billions of years ago. This is like looking back in time. allowing us to study the early universe and how galaxies have evolved over cosmic timescales. Light's limitless reach. The speed of light is a fundamental constant that governs the way we perceive and interact with the universe. It's a speed limit that nothing can surpass, and it allows us to see into the past, observing distant objects as they were long ago. The next time you gaze up at the stars, remember that the light you see has journeyed across vast distances, carrying with it stories of distant worlds and the grand history of the cosmos.